In this video, I'll be discussing the topic of the first spacecraft to touch the Sun and their new discoveries. Thanks to advancements in technology, humanity has been able to send spacecraft close to the Sun, allowing for direct exploration in its harsh environment. Currently, ESA's Solar Orbiter and NASA's Parker Solar Probe are two spacecraft that are approaching and exploring the Sun. We'll be explaining the latest discoveries about the Sun brought about by these spacecraft. On February 10, 2020, ESA launched the Solar Observation Satellite Solar Orbiter, which is currently orbiting the Sun. It is believed that the polar regions of the Sun, which cannot be observed from Earth, hold important secrets to understanding solar activity. The Solar Orbiter is planned to gradually approach the Sun while tilting its orbit to observe these poles. The Solar Orbiter captured detailed images of the Sun's surface at a distance of about 77 million kilometers, which is roughly half the distance between the Earth and the Sun. Here is an actual image obtained at that time. From this image, the presence of previously unknown activities on the Sun's surface became clear. Surprisingly, small flares, ranging from a millionth to a billionth the size of solar flares observable from Earth, were occurring all over the Sun's surface. These newly discovered small solar flares are called campfires. Although small compared to other solar activities, considering that the circle drawn in the bottom left is equal to the size of the Earth, each of these campfires can be considered a large-scale activity for us. At the moment, it is still unclear whether these campfires are simply smaller versions of relatively large flares observable from Earth, or if they are a different phenomenon with a different mechanism altogether. Furthermore, there is a possibility that these campfires may contribute to the coronal heating problem, the biggest mystery of the Sun, where the temperature of the Sun's outer layer, the corona, reaches 1 million degrees Celsius, while the surface temperature is around 5,500 degrees Celsius. In late March 2022, the Solar Orbiter approached the Sun once again. At this time, the distance between the Solar Orbiter and the Sun was about 48 million kilometers, approaching to about 32% of the average distance between the Earth and the Sun, with the heat shield of the Solar Orbiter reaching up to 500 degrees Celsius. Here is a video of the Sun's south pole captured in ultraviolet light during this close approach. In the bright areas, there are magnetic structures called closed magnetic field lines, within which hot material, or plasma, that makes up the Sun is confined. The confined plasma emits powerful ultraviolet radiation, which is why it appears so bright. On the other hand, the dark areas are where the Sun's magnetic field is not closed, allowing plasma to escape into space and form solar winds. This is a video of the Sun captured in ultraviolet light during the same period, showing a new structure called Hedgehog, which was revealed for the first time when the Solar Orbiter approached the Sun very closely, and can be seen towards the lower side of the screen. As it had not been discovered before, the Hedgehog is a relatively small structure within the Sun, but its diameter is about 25,000 kilometers, which is much larger than the size of the Earth displayed in the upper left corner. Currently, not much is known about the formation process of the Hedgehog. On August 12, 2018, NASA launched the Parker Solar Probe. The Parker Solar Probe is scheduled for a 7-year space journey, approaching the Sun 26 times at perihelion. In April 2021, the Parker Solar Probe became the first spacecraft in human history to reach the Sun's corona. This was during its 8th perihelion passage. At that time, it conducted exploration activities such as observing fluctuations in the Sun's magnetic field and collecting particles. The Parker Solar Probe will approach the Sun at an ultra-close distance of about 6 million kilometers, which is about 9 solar radii away, closer than the Solar Orbiter, by utilizing Venus's swingbys during its 26 perihelion passages. At its closest approach, it will pass far inside the orbit of Mercury, the closest planet to the Sun. To withstand this scorching hell, the Parker Solar Probe is protected by a heat shield capable of withstanding temperatures of up to 1,400 degrees Celsius. In addition, due to the large fluctuations in light intensity depending on the distance from the Sun, the solar cell arrays have been engineered accordingly. At the time of the Sun's closest approach, the probe must withstand an energy intensity about 475 times stronger than when orbiting Earth. The Sun does not have a clearly defined surface. The Sun is covered by an extremely hot atmosphere, which is attracted to the Sun's surface by its immense gravity and magnetic field. However, at a certain distance from the Sun, the influence of the Sun's gravity and magnetic force weakens, and the solar atmosphere begins to shoot out into space as solar wind. The boundary between the solar atmosphere and solar wind is called the Alfvén critical surface. Until now, the position of the Alfvén critical surface has been estimated based on images of the solar corona. According to these estimates, the boundary is located at a distance of 10 to 20 solar radii from the solar surface. However, its precise location was not known. In the midst of this, the Parker Solar Probe detected conditions in which magnetic fields and particles met specific criteria at a distance of 18.8 solar radii from the solar surface when it reached its 8th perihelion on April 28, 2021. This is said to indicate that the Parker Solar Probe passed through the Alfvén critical surface. For the first time, humanity succeeded in sending a probe inside the solar atmosphere. Furthermore, during this perihelion passage, it has been confirmed that the Parker Solar Probe has crossed the Alfvén critical surface back and forth multiple times. The fact that the Parker Solar Probe, with its simple orbit, has repeatedly traversed the outside and inside of the Alfvén critical surface indicates that the surface is wrinkled and uneven in shape. Until now, the position of the Alfvén critical surface had not been accurately observed. The observation provides clues to the distance and shape of the Alfvén critical surface from the Sun, which can be considered significant progress. The Parker Solar Probe has successfully captured images of outer space with its onboard camera while passing through the solar corona. The video playing now is a live-action video created by combining real images taken by the Parker Solar Probe within the solar corona. The lines flowing from left to right are structures called streamers that exist within the solar corona. This is the first ever live-action video taken directly from inside the solar atmosphere by humans. The Solar Orbiter and Parker Solar Probe introduced today are expected to approach the Sun even closer in the future, bringing new discoveries. We look forward to unraveling the true nature of the Sun, which sustains our lives. Thank you for watching this video. Please subscribe to the channel and give it a thumbs up. Let's meet again in the next video. Bye.